Now, Objective 7 says, explain the importance of the water, carbon, nitrogen, and phosphorus biogeochemical cycles to the biosphere. And I'm going to warn you up front, this is going to be a lengthy video. So we're talking about chemical cycling, which is the pathways that chemicals circulate through ecosystems. It's going to involve the biotic, the living components, and the abiotic, the non-living components. And we call these biogeochemical cycles. Biogeochemical cycles. We're talking about the water cycle, the carbon cycle, the phosphorus cycle, and the nitrogen cycle. Now, chemical cycling can involve several things. First of all, a reservoir. This is not available to producers. It would be your fossil fuels and your minerals and your sediments. An exchange pool. This is where organisms generally get their chemicals, from the atmosphere, from the soil, or from the water. Biotic community. This is the chemicals in the food chains. They may not ever enter the pool. They may stay in the organisms, okay? So when you're talking about chemical cycling, we're talking about cycling these chemicals through the ecosystems, okay? And human activities have a big impact on this because we upset the balance of nutrients and cause pollution. Now, starting out with the hydrologic cycle, another way of saying water cycle. We're all familiar with this. Water evaporates, and then it condenses in our clouds, and then it falls as rain or snow or sleet. That's called precipitation. And when it hits the ground, it enters our waters there, or the groundwater, the aquifers, and eventually it runs off into the oceans, and then it evaporates again, and it repeats over and over. So it's just a cycle that keeps happening over and over and over. Now the carbon cycle, the atmosphere is the exchange pool. And in the water, carbon dioxide combines with that water and it makes bicarbonate. And bicarbonate ions in the water, you have the same amount of carbon dioxide as you do in the air. It's equilibrium in the water and in the air. So the total amount of carbon dioxide in the atmosphere, unfortunately, has been increasing every year because of us, because of humans. Our use of fossil fuels is the main reason for that. So we're putting in too much carbon dioxide. So we don't do a lot to take it out of the environment. Basically, the only thing that takes it out is photosynthesis. And everything else we do puts it into the atmosphere. Breathing puts it into the atmosphere. Dying puts it into the atmosphere. Using all of our fossil fuels, our factories, our cars, all of those are putting it back into the atmosphere. This causes what's called the greenhouse effect. It's caused by greenhouse gases like carbon dioxide, nitrous oxide, methane. They let the sunlight pass through, but they trap that heat. They reflect the infrared light back to the earth, but they trap it. All those gases up there trap it, and that leads to global warming and climate change. So if our Earth's temperature rises, we're going to see more water evaporating, more clouds forming, and it sets up a feedback loop that could just get worse. It gets greater and greater. We got more water evaporating, more clouds forming, more bad storms because of the clouds and all those things that we are seeing happening now all the time. The phosphorus cycle is a little different because phosphorus never gets into the atmosphere. It's in the sedimentary cycle where the phosphate that producers take up gets put into a lot of organic molecules, and one of the problems, if you have excess phosphorus, it can lead to uh, water eutrophication, where it's over enriched, and you'll see these algal blooms that happen if it's over enriched with too much phosphorus that's um, ending up in the water. But like I said, it never gets into the atmosphere. The nitrogen cycle is the last one, and we have nitrogen in our atmosphere. Our atmosphere is 78% nitrogen, but we can't use it because it's a gas. Some plants have these nodules on the roots, and that makes that atmospheric nitrogen available to the plant to use. Um, Plants use it to produce nitrates, um, or the nitrification. It helps them take in the nitrogen that they need, and they assimilate it from the soil, and that helps them make proteins and nucleic acids. Then denitrification happens, where you convert the nitrous oxide back to a nitrogen gas. But plants get it because of the nodules on their roots, and it is like a fertilizer. It helps them grow. And then they use it, but then animals eat the plants to get the nitrogen that they need. So what about nitrogen in air pollution? It causes acid rain or acid deposition, where the nitrogen oxides and sulfur dioxides, they get converted to acids, and then it combines with water vapor in the atmosphere, and that will affect lakes and forests and reduce agricultural yield.